Welcome to Competency A quiz. In this video, we will work with all types of measurement. Number 1, if a building is 15 feet high, what is the approximate height of the building in meters? Now, they give us a reference of 3.28 feet equals 1 meter. Okay, that makes sense. All right, so what are we really doing? Well, this is a proportion where we need to have feet, 2 meters, okay, and the implication is, okay, well, let's look at our given here. This is our given. So we have 3.28 feet. Well, that's to 1 meter. Well, that's our unit rate. Let's set that equal to what we're looking for. So we have a height of 15 feet. Great. So that's where our 15 goes. But we don't know the meter measurement. Well, this is pretty simple to go through. Well, make sure that you see that the 3.28 is across from the x. So what are we going to do? Set up your fraction. And we need to say 1 times 15. Well, I'm just going to put 15. I'm just going to type in the 15. But I have circled what we divide by. Remember, you always divide by what's across from your x. So that's 3.28, enter, and there's a good decimal. And luckily, we have a very reasonable option. Okay? All right, let's look at number 2. 1 inch is approximately 25.4 millimeters. Which of the following is closer to the length of a standard ruler in millimeters? Okay. All right. Well, some people may already know this. I didn't have that committed to memory. Okay. Well, what do we have here? We have millimeters, 2 inch, and we are given a nice unit rate. First sentence. Okay. So that means we will have, that implies this, that we have 1 inch. Okay. And I could have put inches there, but I'll be honest, I was being lazy, right? When you're taking a test, it is best not to write everything down. No one cares what you write down. That's going to be, if they give you paper, you're going to have to give that to them anyway. No one is judging you. Okay. Always remember that. Now, in some testing locations, you will get wet erase. Okay. Which you should see my hands when I was done with that. So don't worry about, what you write down. So then for the millimeters, notice I didn't even put mm. Okay. It is what it is. Okay. When I wrote that down, you might have said, oh, she's not writing it all down. Well, I'm writing down what's good enough to take a test because that test, no one grades my paper. Okay, you are not turning in these items to be graded. And hey, you can judge my videos, but you're not going to grade me on it. There you go. I'm making life easier for myself. So now what do we have? Well, the question asks us about millimeters. Okay, there's just one thing. Okay, I'm going to put my X there. Inches. And they talk about a standard ruler. Don't you know how many inches are in a ruler? Obviously, 12 inches. Okay. And this is pretty simplistic because, again, it's very convenient actually. I have 1 across my x, so dividing by 1, I'm not even going to bother. So obviously, all I need to do is multiply those two values together and I have what I need. Okay. So 25.4 times the 12. Okay. Now that gives us a good clean value that I didn't even need to round. And also notice that it is mm for millimeters. Okay. All right. So yes, I have a systematic way of writing this down. Now, you may have told yourself, oh, I see what to do. You just multiply that times 12. Well, that's great. Then don't write all this down. I mean, I'm doing it as a teaching moment. and it gives you an idea how you're going to teach proportions when you get in the classroom. But do what you got to do. Go as quick as you can. Get it in, get it done, get your answer, and move on. All right. Trust me, that's what I've done on both of my certifications as far as mathematics. Okay. Now, number 3. If it is recommended for a man to drink 3 liters of water every day, and there are 29.6 milliliters in 1 fluid ounce, okay, what is the closest number of fluid ounces in 3 liters? Then they give us a key. All right, a scale factor of 1 liter equals 1,000 milliliters. Okay, this makes sense. So let's do our setup. But they we're going to use this key they gave us here. However, what are we really comparing? Well, the question is actually asking for ounces. So we are comparing the milliliters, and I'm going to put mm, to the ounces, okay? All right, so what does this imply? This implies that I have, well, let's go here to the given. Here's our given. Notice our given is not the first sentence. That happens sometimes. Okay, so that means I have 1 ounce, that's my unit rate, and then I have 29.6. If you haven't noticed in these questions, looking for your unit rate is a good way to pop quickly to what you need. Okay, so if you find a unit rate, go ahead, write it down really quick while you're reading the problem. Okay, now what do we need from here? Well, they're telling me I have 3 liters, but I can't use that 3 liters as is. I need to explain, or rather convert that quickly. Well, if I have 1 liter, I have 1,000 milliliters. So that means if I have 3 liters, I am going to have 3,000 milliliters. So what do I need to do? I need to just write down my 3,000 because I know that. I quickly converted that, and that's over my x. Okay, now you can see what to do, and you know what to divide by because it's across from the x. So set up your fraction, okay, and that will be 3,000, and then over our 29.6, push enter, and there we go. And yes, we will have to round. And we knew we were going to have to round because of this closest number. That phrase, whenever it says closest, you know you got some kind of rounding going on. So that has to be option C, of course. Okay, let's go to number 4. Number 4, a circle has a radius of 10 inches. Okay, the circumference of a circle is C inches. Which expression best represents the value of pi? Oh, well, that's just set up the circumference and then solve for pi. Okay, so what do you have? You have C equals 2r pi. Okay, so then what do we really have? Well, we have 2 times 10. So I could even do this. I could put in 10. Well, of course, that's 20. Divide by 20 on both sides because we want to solve for pi. Well, really quickly, you know that equals 1, so it's gone. So what do we have? Equivalent to pi, c over 20, and we know that that is c. Okay, that wasn't bad. Okay, if you saw that in the beginning and it kind of confused you, I understand. Of course, you have to read through and just go, oh, okay, that's just a formula thing. Okay, remember, you do have this particular formula is on your reference sheet. So if you think you're gonna forget these formulas, make sure you just refer to your reference sheet provided to you while you take your test. But beforehand, take a look at it so you know what you have to remember and what you aren't required to remember. Okay. All right, let's look at what comes next. Here we have number 5. Which definition describes pi? Okay, take in mind the question we just worked through. Okay. A, the ratio of the circumference, remember a ratio is a fraction, of a circle to its diameter. Well, yeah, well, it's the ratio of the circumference of the circle to its diameter. That looks like what we have because this isn't this the diameter? Yeah, because we can also have not just 2r pi, we can have d pi. Well, if I could write, that'd be great. Then you'd actually know what I'm doing here. Yeah, they're the same thing. The diameter equals 2 times the radius. So I like A, but let's keep reading. The ratio of the circumference of a circle to the radius. No, you can't have just radius. We just said that. It's 2 times radius, so I disagree with this one. Still like an A. Let's go to C. The ratio of the radius of a circle times 2 times pi. Uh, that's circumference. That's not the definition of pi. No, that is the definition of circumference. Now let's look at D. The diameter of a circle times 2 times 3.14. Okay, none of that makes sense. Oh, and I want to make a note about this right here. 3.14 is used in middle school. We asked the non-calculator students. 314 is for the 6th graders and 7th graders taking the regular 7th grade test for now until they make changes, okay? So be aware that that is not going to be the value of pi. 314 is not the value of pi. You need to use the pi button on your calculator or you will have a very serious error when you're asked particular questions, okay? All right. Yeah, it was really hard to break the 7th graders, your AP 7th graders and your 8th graders to change that habit. We teach them through 14 and then we slap them on the hand and say, don't ever use that again. I know. They're like, what? But you've been telling me this forever. You have to get them to use their calculator and learn what to use and what not to use. 314 is merely a way to get a good estimate. Okay. All right. So let's look at 6. A sprinkler rotates and sprays water into a park. Okay, I get it. The portion of the park watered by the sprinkler is in the shape of a circle with a diameter shown in feet. Okay. Which of the following is closest to the area of the circle represented by the sprinkler watering the park? Okay, instead of making you visualize this completely, I added a diagram. Don't depend on a diagram always on your test. There are several questions that you will have that don't give you a diagram. They expect you to know what to draw. In this situation, actually, you need the diagram because they didn't say circle with a radius of. So we need to take a look here. Let's take a look and let's see, what do we have? Well, looks like I have 7 here, 7 there, 7 here. Actually, that's -7. And then that is -7. But we need absolute value, do we not? Yes. So that means this distance is 7 units. Okay. And our units are in, does it tell us a diameter? Feet. We are in feet, 7 feet. That's logical. Okay, I'll go for it. And they want the area. Well, we know what the area is, and we see that it's 7 feet now from our diagram. Great. And it is not in terms of pi, so we will have to put that in the calculator. So that is 7 times 7 or r squared. So we're going to say r squared, push that pi button, push enter. Okay, that's in terms of pi, which is, like I've mentioned before, very convenient. However, that's not what our options are. So push the toggle button and we will need some rounding. And we knew that because of this word closest. So that means the only option that makes sense is D. Okay, let's go to number 7. Okay, it says use the figure to answer the following question. Okay, number 7 says if the side of the square is 6 square roots of 2, what is the area of the circle? Okay, so it's circumscribed inside, and by definition, it is touching each each corner vertex there is touching the circle. Okay, that helps me. All right, so what do we need to do here? Well, let's think this out. What is a square? And notice that they have made sure to show us these tick marks of congruency, and that 100% tells us that that is a square and that all of those sides are the same. But we're not looking for the area of the square, we're looking for the area of the circle. But we should already know this, okay? We know that here in the center, because everything is the same, and we've already seen a problem like this in a prior video. When we go across this way, and then we go this way, we know also from, oh, that was nice. It gave me a little straight line. Let me see if I can get it to do it again. Probably not in a million years, right? Okay, let's see. Nope, didn't do it. It doesn't matter. This side is congruent to this side. That is just by nature, because I know for a fact that we have a right triangle, okay, and that we have these sides that are congruent because it's just the properties of a square. That's just how it is. Okay, so that being said, we have a special right triangle. And I know because of that, that this is equal to 6 and this is equal to 6. Okay, all right. But how could we, I mean, I know that, but how could we prove that? Well, the only way to prove that is just by knowing your special triangle. They're trying to test your understanding of the properties of, I mean, not, well, a square, a triangle inside of a square, and how a square is made up. Okay. So, and we can test that fact. Here, I'll show you what I mean here. Oh my goodness gracious. It'd be great if I could draw correctly. All right. And every time I use those little create your shape things, I can't get them to go away while I'm doing my videos. So you're just gonna have to bear with me. Okay. This is a square. Let's pretend it's decent. Okay. If I have a square root of 2 here, I know this is 1 and this is 1. This is that special isosceles right triangle, and I know that this is a right triangle here. Not the best drawing in the world, but it does the job. That's a 1, and this is a 1, okay? So I can multiply all 3 of those sides by the same thing, and I'm going to get what I have here. Well, let's quit listening to me gab and check that. Think about it. It's logical, and it's just a property that you're required to know. You need to know about your special right triangles. Okay, there's also the 1, 2, square root of 3. Okay, also that one. Okay, not just your primitive right triangles. Okay, and not just this one. Okay, so let's look at what we have here. Let's go second under the radical, and we're going to solve for this side that we're given. Okay, we're going to do it with the 6 that I said I know it is, but I'm using the 1 like a reference. So take a look at it and think it out. Play with it on your calculator. So if we say 6 squared plus 6 squared, right? And I'm saying that that ensures That's my two congruent sides of my isosceles triangle. It ensures that base or that side of my square. Let's push enter. And it does, okay? Now that I know that, and now that I've proven that to you, I mean, you can try it with one too, okay? All right, so we can say 1 squared is just 1. 1 squared is just 1. Push enter, you have square root of 2. So my little iffy, my interesting illustration trying to show you, now you understand what I'm talking about. Okay, so with all that yakking I just said, you know what the radius of that circle is. It is 6. So let me get rid of some things. It's that line. Now that I get rid of all that, ignore the square. All we have done is used the square, what we know about the properties of triangles, right triangles, and the Pythagorean theorem to obtain our radius. Guys, 6 squared is what? Okay, now we have to leave it in terms of pi, okay? But this calculator does it. So let's say it's a number that's not as easy as 6, right? So it's pi r squared. So my r is 6, square that, type in pi, push enter, 36 pi. Luckily, this calculator does that for us, okay? All right, now you can play with that yourself and go look up your properties of special right triangles. You will need to know that for this test. I'm sure there won't be a lot of that, but it will be there. And it's good to be confident. Okay, let's go to the next one. Use this figure to answer the following question. Okay, ooh, what do we have here? No numbers at all. We have two circles inside of a rectangle. And it says, given that the circumference of each circle is 6 pi, what is the perimeter of the rectangle? Okay, well, they pretty much just gave us the answer. Okay. We know that circumference equals BI. Okay. And that is going to be, that's going to equal 6. Okay. All right. So we know that equals 6. This tells me that I have 6 here and 6 here. Therefore, this length is 12. And in the same breath, I know that the diameter going vertically is still 6. So what do I have? I have 6 width and another 6 width and a 12 length and another 12 length. So let's go to our calculator. I'm going to clear this out. My perimeter is 6 plus 6 plus 12 plus 12, enter 36 again. Okay. I'm sure that when you saw that, you was like, oh my gosh, there's no numbers. All they have is some congruency. And the reason they gave you the congruency is because they did not give you that single right angle proving that it's a rectangle. Instead they gave you some congruency. And then with the circle, you knew what it was. And then also they said perimeter of the rectangle. So within their questioning, they defined for a fact that that is actually a proper rectangle with right angles. So that's what made this business of two circles work. And the fact that they said, hey, they both have the same circumference. So they're telling us that they are equal and equal on each side. Okay. All right. This is the last question in this particular video. Thanks very much for watching, everyone. I appreciate all your watch time. That's amazing, and your subscriptions and your liking and sharing and your successes. Keep it up, everybody. Happy testing.